Hello there. In this video, I'm going to talk to you about how to accept incoming command line arguments to an x86-64 Yasm assembly program that is probably linking to GCC and is thus probably a hybrid program under the hood. If you don't know how to program in Yasm assembly yet, check out my other videos. If you don't understand command line arguments yet, check my other videos. I'm going to assume a lot of knowledge here. I'm really just going to show you how to pull the arguments inside of assembly using the GCC setup that they've given you. So just a very quick recap. This is not a command line arguments video. If we have the program echo and we give it like one argument of just the word hello, then it's going to receive one command line argument. In addition to its program name, it's going to receive echo as argument 0 and hello as argument index 1. And it's just going to be able to look at them and say, oh, the user wants me to print this hello string, so it just prints it. And so that's kind of how you can tell a program what to do, either when you're running them directly or having one program automate another program. Anyway, so in our Yasm assembly programs, how do we actually get that out? Well, for starters, we are dynamically linking. Not dynamically linking. We are linking a hybrid program. So I just want to make sure that you understand this is the right video for you. If you're trying to do this in pure assembly, or if you need to know that for some reason, then you'll probably want to watch the next video that I publish. But for now, this is a hybrid program. Hybrid programs, for those of you who don't know, it just means you have modules that are written in different source code, and they're compiled differently, different source code languages. So you might have a source code file that's written in C++, another one that's written in C, another one that's written in assembly, and you compile them all down to their own object files, and then you link them together into an executable. If GCC is part of the linking process, then it's going to end up giving you a main function as your entry point, and it's going to make things a little bit easier. Here's my Makefile. I'm just going to skim through it real fast. This is not a Makefile video, so if you don't understand it, go look at my other videos. But basically, I'm just going to assemble with Yasm, and I'm going to use G++ as the linker, and I'm going to gobble up all of the object files. Here's like a little menu. I have a target for running and building only, and here's the main thing that I'm doing. This is not really a hybrid program. This is just kind of a pure assembly program that is linked with GCC, but you can imagine you could add other source files in C and C++ and still totally get away with GCC. But anyway, I'm just compiling one source code of assembly and compiling it down to an object file right here. And then when it comes time to linking, you can kind of tell here, especially if you're familiar with Makefiles, that I'm just gobbling up all the object files and linking them together into the executable. So that's as far as I'll go there. Again, I've got another video that totally explains a lot more. In my assembly program, again, this is not an assembly video, just for pure assembly. So if you don't understand assembly, see my other videos. But for now, we're just going to say I've got a data section. It's got a couple of null terminated strings. We've got a hello message, a begin message, a goodbye message, carriage return, line feed, string. I've got the system call codes for, printing to standard output and to exit the program. And then I've got the standard output file handle. And then my exit code 0 for success. Again, this is all explained in other videos. So because I'm linking with GCC, my text section here, the actual place where the instructions are, not the data, is going to have a main entry point. So of course, if you had a hybrid program, you could have main somewhere else in a different module and then just call on a function that was inside of assembly. You could totally do that. But for now, I'm just going to say this is the only source code file. So I mark main as global and I put main right here. And then I just make sure that I preserve all of the callee saved registers that I'm supposed to by pushing them at the beginning and popping them in reverse order at the end, and then I return a return value. Standard assembly stuff covered in other videos. But here's the key for getting command line arguments in assembly. If you recall, the ABI specifies that in x86-64 programs, the first argument is always supposed to come into a function as RDI in the RDI register. Or rather, I should say, the first integer argument. I haven't talked about float arguments in any of my videos yet. In the future, you should probably search for other videos that explain how to do float arguments. But for now, all of the arguments I'm talking about in this video are just integer arguments and pointer arguments, which is kind of the same thing. A pointer is an integer. It's a 64-bit integer, but we'll just use it as a pointer rather than using it as an integer. So anyway, first argument comes in on RDI. Second argument comes in on RSI. And you can imagine that basically this is the thing you're probably used to seeing in your C++ programs. If we do this, int main, and then integer argc, and then a character pointer argv, and then an array. Those are those two registers right there. I probably want to change this int to long because, you know, RDI is in 64-bit form, but an integer is an unsigned 32-bit int. I don't like that, so I'm just going to put long. I probably should put unsigned, but I don't really care. Anyway, so we're just going to grab those two things. So obviously RDI is probably pretty easy for you to guess how to use. It's just the number of arguments. In this program, we're going to use it to control a loop counter that's going to loop through all incoming arguments. So we'll start at 0, which is going to be the name of the program. In this case, it'll be, I think, just main is what I called it, which is confusing against the entry point, I admit it. But imagine that my main program that sits in the file system is actually called program or hello or whatever. So that's the number of arguments in RDI. And then RSI, notice how it's a character pointer to an array of characters. That means it's actually a pointer to a pointer. And the reason for that being is that every argument on the command line, like for instance, if I went back here and I said echo hello, let's just do without quotes, hello, you, I've given it 2 arguments. And so when the program launches, it's going to receive 3 total. It's going to receive its own program name at index 0, echo. It's going to receive at index 1, the first argument, hello, and it's going to receive at index 2, the second argument, as you. It prints them both, so how does echo know how many arguments I have? And how does it access all the strings? Remember, argc is the number of arguments, so that's kind of easy, but how does it dereference all of the strings if there could be any number of strings? Well, that's this right here. This whole symbol, argv is a pointer, and it points to an array of pointers, of character pointers. That's why it's written like this, like an array. So it's a pointer that points to an array. So like if you go to that location in memory, then what you will see there for the first 8 bytes is just the address of some other memory location where a string has been stored. Then if you advance that pointer another 8 bytes forward, you know, in memory, because all pointers are 8 bytes or 64 bits, then again, you'll see that that value of that next 8 bytes is actually a memory location that points to another string somewhere else. So these strings could be all over the place, but the pointers to those strings are contiguous in memory, starting with what you were given in RSI. So it's a character pointer pointer, or an array of character pointers, however you want to imagine that. Anyway, so we'll grab those, and then I'll just show you how to use them down further in the code. For starters, I'm calling on an intro function, which just basically prints some stuff. I have a custom function that I wrote called print null terminated string. That's not the point of this video. I have that explained in other videos a little bit, so it's up to you if you want to even care. Right now, I just want to be able to print something. And then let's see. So after we print our welcome message in the intro, then we print another message basically saying, okay, now we're about to start printing all the arguments. Okay, cool. Nothing complicated at this point. Then I have another label here with my preferred style of adding a suffix after the function that I'm currently inside of. And I'm going to say, all right, this is where I initialize my loop. This is not a looping video, so I'm going to skim through it kind of. But I'm basically going to say, let's start the loop as basically saying the index of the argument that we're currently looking at is 0, because we'll start with 0. So that means we'll print, like if our program was named echo, we would also print echo itself and not just all the incoming arguments that the user might have typed. So we're going to start at index 0, and then we're going to use R15 as the current character pointer. So R15, its current character pointer is going to be coming from R13, which was the argv argument. So that means R15 is now going to hold a pointer. Let's see, it's going to hold, well, it's going to be pointing to a pointer. Remember, when you have an array and the array is contiguous in memory, then The pointer itself that points to the array is also a pointer to the first item. That's just kind of the way it works. Like if we have 10 items and it's an array, then your pointer to that array is also a pointer to the first item in the array, if that makes sense. So if R13 was a pointer to an array, it's also a pointer to the first pointer, which itself will then go off to a null terminated string. I know that sounds weird. You got to get used to double dereferencing here. So all we really need to do to access the first pointer to the actual string is take the array pointer that we have and dereference it one time. So remember, we're receiving in argv a pointer to a pointer, or like a double pointer. If we dereference it once, then we should actually just have one pointer to one null terminated string. Anyway, so that's the initialization part. I'm going to start looking at the first string here, and I'm going to say we're at index 0. And then here's the top of my loop. You can imagine this is a while loop. This is not a while video, but there it is. And we're just going to ask first, are we actually done? Do we need to break the loop? I like to do that at the top of my while loop. And how we'll do that is we'll say, all right, R14 is the index that we're currently looking at. We'll compare that to R12, which was the number of arguments. So notice how like right here, we grabbed RDI right into R12 right away. So basically I'm saying, if the index we're currently looking at is greater than or equal to the number of arguments, then we're actually already done. Remember, if we're using zero-based indexing, and you suppose that you have 3 items in your array, their indexes would be 0 and 1 and 2, not 1 and 2 and 3. So that means if the size of your array is 3, like the count, like the argc, that means the last valid index is 2. It's 1 less than the size, it's 1 less than the count. So I'm saying at this point that if we ever reach an index number that is equal to the size, then we've already finished. We do not need to look at the current item. So I'm comparing those two registers, where are we looking at versus what is the count? What is the index we're looking at versus the count? If the index we're looking at is greater than or equal to the count, then that means we're done. I'm going to jump out of the loop to a label called main loop done. So then, that's down here. Basically, we just say goodbye and then we jump to our exit function. And all that does is it just returns from main with some kind of a success code, so just, you can imagine in C++, it's just return 0. So, breaking the loop doesn't really do anything except end the program and say goodbye. However, if we did not jump, then let's see. If we did not jump, let's say if we did jump, we compared it, we realized that we're done, then it's going to jump down to the done. But if we're not done, execution is going to fall through to the next statement. So that means we're going to end up doing something with the current item inside of our loop. So what are we going to do? We're going to dereference R15. If you recall, remember I said R15 was your pointer to a pointer. It was your double pointer there. If we dereference it once, then instead of being a pointer to an array of pointers, it's going to be a pointer to one string, one character that starts one string. So dereferencing it once means, I put brackets around the double pointer. It's now dereferenced once. That means RDI is going to receive a pointer to one string. So I'm just sending this into my function. My function takes 2 arguments. It wants a pointer to a string and it wants the file descriptor to print to. Again, other videos explain, printing to standard output, but I'm just going to print the string. So this part right here should actually print the argument. And then after we're done with that, well, maybe I should change this so that it's a little bit more clear. I'm going to maybe push this down and say end increment. So these lines up here actually do something. They do the printing by dereferencing. And then here we just sort of increment along the array of pointers and jump back to the top of the loop. So what are we doing here with R14? Remember, R14 was the index that we're currently looking at. So we start looking at index 0. Line 83 is going to say, let's next look at index 1. And then this part right here, add 8 to R15. That just basically means, remember, R15 was the double pointer. The double pointer, like I said before, it's looking at an array of pointers. So it's actually a pointer to a pointer. If I increase the memory location that R15 holds, then it's now looking at the next pointer. It's moving through the array. R15 at that point would no longer be a valid pointer to the original array. It's sort of like a running pointer. It's kind of like scanning all of the pointers. But a pointer is 8 bytes. So if we're just looking at the first pointer and we increase the memory location that we're looking at by 8 bytes, now we're looking at the second pointer. So then on the next iteration of the loop, if we dereference, then we're going to end up dereferencing to the second string. Then I just print a little new line here. Honestly, probably should have put that up top. Sloppy code, I was doing this quickly. And then we jump to the top of the loop. So then we just basically keep going up to the top of the loop and printing arguments and advancing to the next pointer. And we just keep going at it. Let me see if this works. Hopefully I didn't mess this up while I was screwing around. All right, so I'm going to do this. Make run. Okay, so under the hood inside of my Makefile, maybe let's open the Makefile real fast just so you can see. I'm just going to nano it real fast here. Under the hood, when I call the program to run, notice how I'm giving it arguments. You can see right here on this line, or actually let me get the line numbers up. You can see on line 48, I am calling my executable, which is named main. In the Makefile, I'm using a variable, so don't worry about that. But I'm giving it 4 arguments. And I'm just saying first arg, second arg, third arg, fourth arg. So that's why you see that printed in the previous screen. It's just going through all of the arguments that I gave it. It's saying first arg, second arg, third arg, fourth arg. Notice how it knows when to stop because of the argc that came in on RDI. Now that the program is built, I've got my main executable, which I named main, which I said before was kind of confusing. Now that I've got it, I can just execute it again and give it like one argument of like hello. Notice how it prints hello on a line by itself. You, do it again, dudes. And notice how every argument I give it, it just prints it no matter how many I do. I can go A, B, C, D, E, F, G. I could probably do this so many times that I exhaust, a long integer, which would be a horrible endeavor. But yeah, everything that I put on there, it just loops through it and prints it. So when you are linking with GCC, because you're probably using a hybrid program, or at least if you're just linking with GCC, GCC makes it really, really easy to access the command line arguments. Imagine now, instead of just printing these things, you used them to somehow decide what your program was going to do. Maybe the user will give you a subcommand, like if you're a Git user, we say Git status, right? So the Git says like, oh, Git launches and it goes, you want the status of something? Yeah, sure. So in your program now, you could read what the user typed, figure out a way to parse it and interpret it, and then have your program's behavior adjust to whatever the user typed in. Okay, that's it for this video. The next video I'm going to post is how to do basically exactly the same thing, but using pure assembly without linking against GCC. So like LD is going to be the linker, just like pure assembly, no extra libraries. Okay, thank you so much for watching this video. I hope you learned a little bit of stuff and you had a little bit of fun. Tell your friends, and I'll see you in the next video. Hey everybody, thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. Sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? Just send me a comment, whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.